on chapter 5. The name of the chapter is chemical bond, and this is the first part of the chapter. So let us move forward to this topic. Dear students, name of the chapter is chemical bond. We know all substances consist of molecule and atom. Each of these matters has its own atoms. Out of these substances, atom of one or more elements make a substance molecule. Atoms do not maintain molecule of substances. They remain highly organized. The force of attraction that binds two atoms in a molecule is called chemical bond. This bond may be of various types, ionic bond, covalent bond, metallic bond, etc. This chapter will focus on compounds made of ionic bond, covalent bond, or process of bonding and their properties. Now we will learn about the valence electron. The number of principal electron at the outermost principal energy level of an element is called atomic picture. This picture of potassium, that in the last orbital potassium has only one electron and the valence electron of potassium is 1. If you observe the oxygen, the outermost physical energy level oxygen has 6 electrons. So the electron number of oxygen is 6. Like this way, the nitrogen valence electron will be 5 because last orbital nitrogen has 5 electrons. When the fluorine valence electron number will be 7 because in the last principal or outermost principal energy level it has 7 electrons. The phosphorus valence electron is 5 because the phosphorus electronic configuration has 5 electrons. Now chlorine's valence electron is 7 because last or outermost energy level has the 7 electron, and calcium valence electron is 2 because in the outermost energy level the calcium has only 2 electrons. Now come to the valency. You already know that atoms of different elements donate, accept or share electrons of their outermost energy level with atoms of other elements to form molecules. The capacity of bonding of an atom with another atoms of an element while forming a molecule is called valency. Now usually valency of hydrogen is taken 1. That means valency of element is determining the number of atom of that same element. Hydrogen or chlorine, one of its atom can bond. That means how many hydrogen atom that element can hold, or how many chlorine atom that element can hold, it is determine that element's valency. An atom hydrogen bond with another atom's chlorine to form hydrogen chloride molecule, and so the valency of chlorine is 1, also 1. Again, an atom of oxygen bond with 2 hydrogen to form water, that means H2O. So valency of oxygen is 2. And 1 atom of sodium bond with 1 chlorine atom, that means sodium chloride. Therefore the valency of sodium is 1. That means we can determine the valency of that element by how many hydrogen or how many chlorine they can are bonding with that element. Some elements have more than 1 valency, and there are 4 kinds of valency. Then some elements are has 1 valency. Here is written how many kinds of valency. 4. There are 4 kinds of valency. First one is highest valency. Second one is active valency. Third one is latent valency. And last one is variable valency. If we think about ferrous chloride and ferric chloride, here because it can hold 2, that means here the iron's valency is 2 and here the iron's valency is 3, and that's why this one name is ferrous chloride and its name is ferric chloride, which is used where the highest valency of an element used, that name with the name it will be added, and here us will be added if the lowest valency is active in a element, in a compound. That time in the name there us will be added with the name, that means ferrous chloride and ferric chloride. Here the valency of the iron is 2, here the valency of the iron is 3. And what is the highest valency? We know the iron's valency is, there is 2 valency, one is 2 another is 3, that means highest valency is 3, and where it is used the high valency, it is known as the active valency. In case of ferrous chloride the active valency is 2, the active valency is 2, but in case of iron we know the highest valency is 3. Then if we subtract from highest valency to the active valency, we will get the latent valency, we will get the latent valency, and which element shows several valency, that valency is known as the variable valency, that valency is known as the variable valency. That how many types of valency are there? 4 types of valency: highest valency, active valency, latent valency and variable valency. Which element have several valency? That known as variable valency, and that element's highest valency is known as the highest valency, and which valency is which valency is used by that element to form a compound, that is known as active valency. If we subtract highest valency and with the active valency, we will get the latent valency. Now here is the valency of different elements given. The hydrogen valency is 1, fluorine 1, chlorine 1, bromine 1, iodine 1, and the valency of sodium also 1, potassium 1. Carbons is there is 2, then 2 and 4, magnesium is 2, aluminum 3, and iron is 2 and 3, and copper also has 2 valency, that 1 and 2, and zinc has only 1 valency, that is 2. That means if any element have only 1 valency, that time that elements if make any compound, its latent valency will be 0. And if you observe here, by seeing 1 hydrogen bond with 1 chlorine, that means there both is 1, that's why there is not written anything any number, that means hydrogen chloride. If you think calcium's valency here 2, because it can hold 2 chlorine atom, and that's why we have to write calcium chloride, that means CaCl2, it is calcium chloride. Even come to the aluminum, the valency is 3, then we have it can hold 3 chlorine atom, that's why we have to write AlCl3, that means aluminum chloride, we have to say aluminum chloride. And like this way, if you think about the zinc, here zinc chloride, the zinc can hold 2 chlorine, the valency of zinc is 2. If you come to lead chloride, lead dichloride, there is lead has 2 valency, it has variable valency. Here the valency of lead is 2, because here is written 2, and here the lead's valency is 4, because there lead tetrachloride, the lead in the second compound, lead can hold chlorine atom, that's why its valency is 4 and it is known as lead tetrachloride. Now in the nitrogen, nitrogen also has variable valency, and in ammonia the nitrogen hold 3 hydrogen atom, that's why its valency is 3, and again in the dinitrogen pentaoxide nitrogen hold 5 oxygen, its valency in dinitrogen pentaoxide in 5. Now come to the radicals and their valencies. Sometimes a bundle of atoms form more than one element combined together receive positive or negative charge and act as an ion of an element. They are called radicals. We already learned about radicals in our previous class science book. Radicals may be positive or negative charge. The number of charge of the radicals is their valency. For example, hydrogen atom and one hydrogen cation combined with one nitrogen atom to produce radical of ammonium. That means ammonium has ammonium ion, it is a cation. Since its number of charge is +1, so its valency also 1. Charge may be positive or negative, but valency is always the number only. That means valency will not show the positive or negative charge. Now come to the ammonium. The ammonium's charge is +1, the valency is 1. The carbonate CO3 and its this 2 minus, that is shown the valency and its charge is -2. Hydrogen carbonate, that HCO3 minus, that means charge is -1 and valency is 1, and this radical group you have to memorize for your MCQ. This part is too much important. Last one is phosphonium. Phosphonium pH 4 plus, that means charge is 1 plus and valency is 1. This charge is important for your MCQ. Now, chemical formula of compound. The symbol and the numbers belonging to the atom that together produce a molecule of the compound are used to express compound. For instance, 2 hydrogen atoms and an oxygen atom combined into a molecule of water. Here is the chemical formula of water, then H2O, water's molecule. Therefore, a chemical formula is the way of expressing the compound molecule through the symbol formulas. Then and the numbers of atom of the elements and the radicals. The number of atoms and the radicals are written in subscript. Now the system of writing chemical formula that we have to learn. The number of atom there is an element's molecule has to be written in the subscript after its symbol. Then since nitrogen molecule has 2 atoms, its formula is N2. One molecule of ozone has 3 oxygen atoms, so its formula is O3. Some elements like all metals do not form any molecule, which are expressed through their symbol only. That's why iron is written as Fe only, and the same system is applicable to all inert gas too. Like as in helium, we have to write only He. Now come to next system. Sometimes a compound molecule is made of atom of 2 different elements. If their valency is not divisible by a common number, then the symbol of both elements are written side by side and each of the following by the valency of the other. That means if you think about H2O, here we know the hydrogen valency is 1 and oxygen valency is 2. And here this 2 is written with, that means this will become here and this will be come here. That's why it is written H2O, because one is no need, one is for hydrogen, that one is not written here, and 2 is for oxygen. By seeing this, we can easily understand the valency of oxygen is 2. The symbol of oxygen comes followed by the valency of aluminium. An example, aluminium oxide. In the same way, the valency of calcium and the chlorine 2 and 1 respectively, and calcium chloride, supposed to write Ca1, that 1 is no needed to write, that's why we have to write CaCl2. That is the system of writing the chemical formula of calcium chloride. And come to the next point, the valencies of the two elements are divisible by a common number than the quotient after dividing will be written following the formula started in the rule B. For example, carbon dioxide is a compound made by carbon and oxygen, and valencies of carbon and oxygen 2 and 4 respectively. Here he said carbon dioxide, and we know the carbon. Here the carbon's valency is 4, the oxygen valency is 2, and we can cut with 2 because there is common factor. So this 2 will cut with this 4 and we can write CO2, and this also followed by the second system, second system. And again we know carbon monoxide there C2O2, that means the carbon has two variable valency. Here in carbon monoxide, carbon's valency 2 is used and oxygen's also valency 2 used, that's why it cut down and it becomes CO. That means carbon monoxide's formula becomes CO and the carbon dioxide formula becomes CO2 because of the we can easily divide with the same number, common number with these two symbols valence. Now come to the molecular formula and structural formula. The formula of using symbols and the number of the atoms of the kind of elements that constitute of the molecule of an element or compound is called the molecular formula or chemical formula. We have just learned about it. And again, the formula of expressing a molecule through the symbol and the bond of atoms. The formula expressing a molecule through the symbols and bonds of atoms, otherwise known as the organization of atom, is called the structural formula. For example, 3 carbon atoms combined with 8 hydrogen atoms and produce propane. That means C3H8 molecule. In the propane there is 3 carbon atoms. First 3 carbon atoms join with each other with one bond, and rest of the valency fill up with the hydrogen atom. In this propane, that is C3H8, is the molecular of the chemical formula of the propane. Again, the 3 carbon atoms here bond with each other like a chain, and rest valencies get completed with hydrogen. Thus, the valency of each carbon becomes 4. If you look, first the 3 carbon join with each other like the chain. There, in this side, 3 carbon raise the 3 hand, that means 3 valencies that will fill up with 3 hydrogen, and this side also fill up with 3 hydrogen. But in the middle, the carbon only 2 valency is raised, and that's why this middle carbon hold 2 hydrogen atom. It joined with 2 hydrogen atom. Again, the molecular formula of water is H2O, and written in the structural formula, that means O is bonded with 2 hydrogen in this way, and this is called the hand or arm of the oxygen, and valency is known also the arm of the oxygen. Now come to the methane. The CH4, and which is molecular formula of methane, is written in the structural formula. That means 1 carbon is added with 4 carbon. And carbon has 4 valency, and the total 4 valency is completed with the 4 hydrogen atom. The structural formula tells us how many atoms of which elements are there in a compound and how they bonded with each other as well. Now come to the octet and duet law. When we learn about the inert gas, we have learned that every element wants to turn into outermost energy level fill up. And all elements tends to make the electronic configuration of inert gases at their outermost energy level. All inert gas other than helium have 8 electrons at their outermost energy level. When constituting molecule, an element obtain the electronic configuration of inert gases holding electrons by means of donating and accepting or sharing electrons. This is known as the octet rule. That means in anyhow an element's electrons wants to get the outermost layer complete. That means it wants to get 8 electrons in its outermost orbital. That is known as the octet rule. The central atom carbon of the methane, that means CH4 molecules, has 8 electrons in its outermost energy level. 4 of these 8 electrons are carbons own, and while the rest 4 come from the hydrogen. Look, 1 electron here from hydrogen, another is from carbon, and in the last orbital 4 electron is of the carbon and rest 4 electron of the hydrogen, and that's why, and look, if you observe that electron is stay in the pair, and that is known as the duet rules. And due to some limitation of the octet rules, scientists have presented a new rule which is called duet rule. This new rule is more modern than the octet rule, and it has better utility too. Very much like the inert gases having 2 or 8 electrons in their outermost energy level, when constituting a molecule, atom will have 1 or more pairs of electrons in their outermost energy level. This is the duet rule. This means any molecule's atom will bear 1 or more pairs of electrons at the outermost energy level. And the barium atom at the center, barium chloride has 2 pairs of 4 electrons in the outermost energy level. And bromine fluoride has 3 pairs of 6 electrons at the outermost energy level. The carbon's atom at the center of methane has 4 pairs of electrons at its outermost energy level. Not only that, besides the central atom, other atoms like chlorine will have 4 pairs of electrons at the outermost energy level. Likewise, fluorine has 4 pairs, and hydrogen has only 1 pair of electrons at their outermost energy level. Now come to the inert gas, and we have already learned about the inert gas. Why they are called inert gas? Because their outermost energy level is filled up with the electrons, and that's why they get the stability. That's why they don't want to donate, or they don't want to share, or they don't want to accept any electrons, and that's why their name is become inert, and their all of them are gaseous, stay in the gaseous form in the not natural temperature. That's why they are called the inert gases, and they have the stability because their outermost orbital is filled up with the electron, and every element want to get this type of stability. For that, they donate, or they accept, or they share electrons to get that type of stability. Dear student, this one is your homework number 13. You have to make 5 MCQ from this part of your chapter, and you have to submit on Saturday from 9 AM to 3 PM. dear students, I have finished my today's topic. Hope you have understood the chapter properly. This chapter is too much important, like the periodic table, and practice more and more at home. Stay safe, stay good. Thank you. Allah.